All right, so we're taking a look at the fan cart physics gizmo, and there are a couple of prior knowledge questions, and try to answer those as best you can. And the first instruction, the warm-up, tells us to place fan A on the cart. There it is. So grab fan A. Notice we can change the direction. So here it's positive, negative, just changing the direction there. And we can turn it on and off by clicking on this. Right, push that. You see, there it is. Okay. Let me turn it off. It says, what direction is the air pushed? The air is pushed to the left. Okay. Then you press play and observe the cart. So we turn this on, we hit play, and there's the cart. What's it doing? It's moving to the right. The velocity of the cart is its speed and direction. And then you can hit reset. So here's the reset button. Click the chart tab and then hit play. And you can see that there are a couple of graphs here, right? So the position bar chart is increasing, and then the velocity is increasing. Notice that the acceleration is staying the same, right? So the velocity changes, but the acceleration seems to stay the same. All right, so now we're ready to move on to activity A. It says click reset and remove all fans from the cart. So reset, remove the fan from the cart. And then we're going to form a hypothesis. It says, what will the motion of the cart be like when there is no force at all? And notice there's no friction in this model. All right, so we're not dealing with any kind of friction here. So when there's no force at all, we have to, so what do you think is going to happen? And predict. Suppose a cart with no fans has a starting velocity of 2 meters per second. Right. What will be the velocity of the cart when it reaches the wall? So when it gets to the other side, how will the velocity have changed? Okay, now we're going to check there are no fans in the cart. In the description tab, so we go here, we're going to set the initial velocity of the cart to 2 meters per second. That's all the way to the right. And then we hit play. What do we notice about the velocity? Notice the velocity stays the same the whole time. You can reset, do that again. The velocity stays the same, the acceleration is 0. Interesting. Okay, now we're going to reset. Place 2 fans in the cart and point them in opposite directions. Reset. I'm going to put A there and B. I'm going to switch the direction of B. So I've got 2 fans that are going in opposite directions. I'm going to turn on both fans and hit play. What do we see happening? Is the velocity changing? No. What's the acceleration? 0. Do that one more time so you can see. Okay, so now we're going to look at the graph tab. What do you notice about the position versus time graph? Notice it's a straight line. Straight line means constant velocity, right? Look at the velocity time graph. Notice it's a horizontal line. Constant velocity of 2 meters per second. When we look at the acceleration versus time graph, we see that it's 0. 0 acceleration. This is an illustration of Newton's first law. Okay, and then how do these experiments show Newton's first law? Because in every experiment, the total force was 0 and the acceleration was 0. And so if the total force is 0, the acceleration is constant. That's it. Okay, so that's activity A, which is kind of helping you figure out Newton's first law. And now here's activity B. Click reset. Set the initial velocity of the cart to 0. So we go to the description here, set the initial velocity of the cart to 0. And it says place all 3 fans on the cart, all blowing to the left. So fans A, B, and C. Okay, experiment. Turn on the fan. So all the fans are on, click play, and watch the cart. Then select the table tab. So there it is. We look at the table. All right. So in the table, they're asking us, scroll to the bottom of the table, what is the final velocity of the cart? So you can actually read the velocity here. Go down to the bottom. So you got to use this thing to scroll on the side. And you see the final velocity at the very end when it reaches 10 meters is 4.9 meters per second. And how long did it take the cart to reach the end of the track? 4.08 seconds. So here's your velocity, here's your time. Acceleration is how the velocity has changed. So they want to know what is the acceleration of the cart. And they tell you how to do this. You divide the final velocity by the time. So 4.9 divided by 4.08, and you should get 1.2 meters per second squared. Right, don't forget the units, meters per second or meters per second squared. And then you look, that matches with the acceleration here. Notice the acceleration is the same the whole time, 1.2. And one way you can calculate that if you didn't have this chart or table would be the change in velocity divided by the time. Now we're going to form a hypothesis. How do we think the mass of the cart will affect the acceleration? So you come up with a hypothesis. How do you think the number of fans will affect the acceleration? So the number of fans has to do with the force. More fans, more force. That's it. Okay. So now it says select the bar chart tab. So we're going to go to the bar chart tab and show numerical values. Okay, so we can actually see those, right? 10, 4.9, 1.2, just like we saw before. For each of those situations, record the acceleration of the cart. So first, we're going to reset this. Description. Okay. And so we're not adding any of these masses in the first one. So here's the first situation. 3 fans, 0 mass unit, and we're going to turn on 1 fan. Right? It says number of fans turned on 1. And you hit go. And you can see from the bar chart what is the value of the acceleration. So you put that into the first row. Right? Then you repeat this, turn on 2 fans, and do it again. And then for the next one, right, all 3 fans are on, and I accidentally went backwards. I think we were up to this. So all 3 fans, now all 3 fans turned on. Looking at the bar chart. And again, you can see the value of the acceleration. Now we're going to put 2 mass units on there. So reset. Put these masses on. And 3 fans, only 1 mass unit on, or one fan on. Turn on, you can see what the acceleration is. Okay. Reset. Turn on 2 fans. You can see what the acceleration is. Reset again. Turn on the other fan. All 3 fans on. That's it. Then on to number 5 in activity B. It says, how did doubling the force affect the acceleration of the cart? So in other words, when you went from 1 to 2 fans on, what happened to the acceleration of the cart? Right. So we could go back here. So even in this situation, right, first the acceleration is 0.2, then, so this would be, for example, the first 2 anywhere. So 0.2 is the acceleration, and then when I double the force, right, I double the number of fans, what happens to the acceleration? Before it was 0.2, now it's 0.4. So how much has the acceleration changed? And then it says compare the first and third lines of data. So that was tripling the force, right? What happened when we tripled the force? So you can see it was 0.2, then 0.4, then 0.6. So if we triple the force, how much does the acceleration change? And then the cart with 2 mass units and 3 fans has twice the mass as a cart with just 3 fans. So a cart has 2 mass units that we can see. Okay, so if we double the mass, what happens to the acceleration? Right, so you got to look back at the chart. The first and the fourth lines you would use to compare that, and then the second and the fifth and the third and the sixth. You're comparing those. So draw conclusions. Newton's second law states that the force is equal to the mass times the acceleration. F equals ma, right? Or the total force equals the mass times the acceleration. And it can be rearranged, A equals F over m, or F divided by m. So how does this experiment demonstrate Newton's second law? We just went through it. We saw what happens when we double the force, when we triple the force, what happens to the acceleration. When we double the mass, what happens to the acceleration, etc. Now for the challenge. The unit of the force is the Newton. So 1 Newton, it's the unit of force, required to accelerate 1 kilogram object at a rate of 1 meter per second squared. Suppose each of the fans supplies a force of 2 newtons. Use Newton's second law in the Gizmo to find the following. So what is the mass of the cart. So if you know that each fan is supplies 2 newtons of force, and you turn that on, right? So you've got 2 newtons, that's the force, and then you can see what the acceleration is. So we go back here to try this. We take the masses off the cart. I have to reset this. Oh yeah, so you can't take the masses off until you reset this. Turn it on, you can see what the acceleration is. So again, if the force is 2 newtons, and this is 0.4, you're going to do 2 newtons divided by 0.4. Okay. Let's see if taking the fans off changes this at all. Oh, if we take the fans off, then the acceleration is 0.8. So each of the fans has a mass, right? So you got to figure that out, right? This fan, add the fans, see how that changes it. Okay, so it's not just as simple as taking the mass of taking the force and dividing it by the acceleration, because that'll give you the mass of the fan and the cart together. That's my daughter, by the way, making noises. So anyway, good luck with the challenge, and don't forget to send this to us when you're done.